Okay, so these are the notes that you'll need for section 5, chapter 5, section 1, and it's dealing with, this first section deals with exponents and using exponents and how to use exponents and where to use exponents and how they go together and all kinds of things. So what you'll want to add in your notes, and you might need to pause the notes right now and write the definition part down, okay, because what we're going to look at are all the different things that you can do with exponents. And we're going to take all these things that you can do with exponents and we're going to use them, and they're going to help us solve all kinds of polynomial type of problems. That they can be really super complicated or really super easy. So we've got to understand these basic things and how they work, and it'll make our life in the long run a lot easier and more manageable. And so on the right hand side, on the far right over here, you have several different examples. You don't necessarily need to copy those down unless you want to have a specific example to go with your definition. We're going to work through several of these starting right now. All right. So the first example that we're going to look at is just taking numbers that we know, numbers that we use every day, and we're going to use these numbers to solve out some of these power rules. And so we've got -4 times 2 to the 5th squared. And what we need to understand is that this 2 on the outside, the 2 out here, when you go back and look at your rules, he's going to multiply with all of the exponents on the inside. And even though it's not written down, one of the things that we need to remember is this is 4 to the first power. 4 to the first power. And what kind of 4 to the first power? A -4 to the first power, the number -4, and that's really important. So what we're going to do is we're just going to take this 2 and we're going to multiply it with both of the exponents inside our parentheses. So what we're going to end up with is something that looks like this. -4 to the 2 times 1 power times 2 to the 5 times 2 power, which would be 10. And what that's going to end up being then is -4 squared. That's -4 times -4, 16. And then 16 times 2 to the 10th, which is going to be some really large number. But you can punch all this into your calculator, and when you do that, when you punch it all in, you're going to get 16,384. And that's just a really simple way to clean up a problem with your exponents using your basically it's a power of a product is the rule that you're using on this guy. So another example would be, 11 to the 5th divided by 11 to the 8th. And you have a lot of different ways that you can look at this one, but this is going to be, with division, it's going to be quotient of powers. And so what we do is we're really interested in this power, and we're really interested in this power. And basically, when you see division, you're just doing the top number minus the bottom number, and that's nice. Like, we can handle that. So the base stays the same. That 11 stays the same. It's the 11 on top and the 11 on bottom. But what we're going to do now is we're just going to take that top exponent and subtract the bottom exponent. Now, don't forget that we are still inside our parentheses at this point. We haven't done anything yet outside the parentheses. And so when I do 5 minus 8, that is going to be -3. So that's going to give me on the inside then 11 to the -3 power. And then I still have that -1 on the outside. Well, what does that mean? That means that I'm going to have a power to a power, so they multiply, just like in our very first example, and I'm going to end up with 11 to the -3 times -1 power. And -3 times -1 is +3, so I wind up with 11 to the 3rd power. And if you want to punch that in on your calculator and double check it out, it should be 1,331. Okay, now what to do? We've got variables instead of numbers, so life gets a little bit different, but don't panic. If the bases are all the same, and the bases are these guys right here, these are all b's, these are all our bases, and all of the bases are the same. Since all of the bases are the same, and all the numbers are multiplying, then what we do is we just add up the exponents. So I still keep a base of b. That doesn't change. We don't have 3 b's here, okay? What we have is b, and then with our exponents, we just add all those exponents together. I'm going to have negative 4 plus 6 plus 7. And when I add all of those guys up, that will give me my reduced answered form. So negative 4 plus 6 is 2. 2 plus 7 is 9. So my final answer is going to be b to the 9th. All right, here's another example, a little bit more messy. And again, with variables running around, so again, it's hard to tell exactly what's going on, but we can just start looking at some things that we understand. One is we've got division, okay? And if you look in here, you can see we've got some division going on. And we also can look and tell that we've got an R and an S. Well, those bases are different, so we cannot combine them together. The next thing that we're going to look at is we've got a power outside of the parentheses. And anytime we have a power outside the parentheses, what we're going to do is we're going to take that guy and multiply him with all the exponents inside the parentheses like we did on our first example. This is going to give us r to the negative 2 times negative 3 power over s to the 3 times negative 3 power. And so now you're working out your math. And we're going to write everything with a positive exponent when we're done. So it'll all look really nice. And this is going to be negative 2 times negative 3 is r to the 6th. And 3 times negative 3 is negative 9. So I would be right here, r to the 6th and s to the negative 9th. Well, if I have a negative exponent, the way that I handle a negative exponent is by looking at the reciprocal of just the thing it's with. So right now, this negative 9 right here, this negative 9 is only with the s. So only the s. I need the reciprocal of 1 over s. And it looks really strange, but this is how you're going to simplify this guy. It's just going to be r to the 6th. He doesn't change at all. He's finished. But now I'm going to look at now s to the 9th. And that's how you handle a negative exponent. My s is in the bottom with the negative exponents in the bottom of the fraction. And in order to get my s to be positive, I move it to the top of the fraction. I move it up. And that's all we did right here. And so it's a strange thing, but that's how you handle these guys. You take a negative exponent and either move it to the top of the fraction if it's in the bottom, or the bottom of the fraction if it's in the top. Okay, here's one with numbers and letters. So we've got a lot of things going on here. And again, we want to end with positive exponents. So let's just look at a couple things at a time. First off, let's look at 16 and 2. Don't forget what you learned in 3rd grade. 16 divided by 2. We learned that a long time ago. Don't let that part be hard. 16 divided by 2 is going to be 8. So we're going to take care of those two guys, and we're going to have an 8 right here. So 16 and 2, these guys are done. Okay, we've gotten them taken care of. Go to the next one. M to the 4th. We're looking for anything else that might have an m in it that we can use our rules of exponents with, and I'm looking around and I don't see anything else with an m in it. So we're just going to come over here and right next to this 8, we're going to write m to the 4th. All right, the last one then deals with go to the next guy now. So m's are done. So this guy's done. And so our last guy then is going to be the n. And so we're looking right here. I've got an n in the top of the fraction and an n in the bottom of the fraction. And if I've got n's on top and bottom, I subtract the exponents. So this is going to give me then n. This is going to give me n. And then I subtract the exponent, top minus bottom, okay? So this is going to give me negative 5 that's my top exponent, minus the bottom exponent, negative 5. And so something really interesting is going to happen here. This is going to give me 8m to the fourth n to the 0. Well, anything to the 0 power is 1, and that's one of the rules that we looked at on that very first, at the very beginning of the lesson. Anything to the 0 power is 1. Doesn't matter what the number is, it's 1. So when we finish this problem off, we're looking at 8m to the fourth times 1, okay? And so our final answer then is just going to be 8m to the fourth. And when you've got a big, long problem like this, always go a little bit at a time. And as you use stuff, it might not be a bad idea to mark it out so that you know that you've used it and you're finished. All right, last problem. There's a lot going on here, and you can't forget your order of operations. So for this problem right here, we're going to start on the top. The reason we're going to start on the top is because I've got this 2 up here in the exponent outside of the parentheses. So if I have a 2 in an exponent outside of parentheses, I'm going to multiply it with all the exponents on the inside. This is going to give us, on the top, x to the negative 6th, y to the positive 6th, over x to the 5th, y to the 6th. All right. Start from the left-hand side. We've got x over x here. We've got x over x. And when you have an x in the numerator and an x in the denominator, you subtract the exponents. So this is going to give me then x to the negative 6 minus 5. And then look over to the right-hand side now. We've got y over y. And what I'm going to do on this guy is the exact same thing. I'm going to have y to the 6 minus 6 power of the top minus the bottom. And when I get done with all my math, I want positive exponents. I want positive exponents. So this is going to give me x to the negative 11th, y to the 0. Well, we learned earlier that anything to the 0 power is going to be 1. So that's just going to be y to the 0 power. That's just 1. So this guy right here, this y right here, is going to be a big ol' 1. And so now that just leaves me with x to the negative 11th times y to the 0 times 1. And so on my x to the negative 11th, in order to make this a positive exponent, it moves from the top of my fraction to the bottom. And that's all that there is for that guy.